through two others, which will provide the links for everyone if you want to see the previous sessions. One of those was on Power BI and Copilot usage, and the other was on data factory or data pipelines in Fabric and looking at those as well as data flow Gen 2 experiences. Today, we're going to be focused on the data science and engineering aspects of this and how specifically you can transform your healthcare data using these copilots. One of the things I think that's very interesting about this is the ability to not only transform or reduce timelines for deployment for your customers, but one of the other aspects of it is how quickly it is to come to market with your business analysts and your end users using this copilot. So today, the agenda that we're going to be going through, we'll do a quick introduction of the team. We'll also talk about what are Fabric copilots. What does that mean? And then we'll spend a majority of our time going through discussion and demo of use cases, and iLink, our partner, will be focused on those particular pieces. And then we'll do an open Q&A and then follow up with next steps with Christina. So with that, moving on, we'll talk about what are copilots or who is your team. So first of all, my name is Greg Katz. I am a principal data and AI technical specialist at Microsoft. Been at Microsoft for 22 years. In the last few years, been focused on healthcare customers, both provider, med tech, and just a number of customers that I've been working with. Ron and Munya, can you guys introduce yourself real quick?
Sure. Hi, my name is Arun Krishnan. I lead data science and AI for iLink. I've more than 26 years of experience in the data and AI space across the US, Singapore, Japan, and India, and across both academia and industry. I was also an entrepreneur at one time. So, Munna.
Thank you, Arun. So, hello everyone. My name is Munna Gupta, and I have over 12 plus years of experience in data science, and I'm working as a senior technical specialist in iLink. Thank you.
Perfect. And just from a sound check perspective, Luna, if you can check on your voice because it's coming in a little garbled. So we want to make sure that everyone has a great experience. So please check on that in the background. All right, moving on. So one of the things that we want to discuss is, what the heck is a copilot? What are we doing today with copilots? What's the different experience that we have and our customers have from an experience perspective? And the big thing that you'll find with copilots is it's an enablement tool. Just like we've had calculators, just like we've had all sorts of assisted devices in the past, copilots is an opportunity for us to have assistance with AI. And when we look at AI, there's a number of aspects we can do, things like summarization, writing papers, composing content, classifications, translations. All of these types of pieces provide a lot of information, augmentation of what you can do as a human with the experiences. Today, moving on, we're going to talk about what that means in Microsoft Copilot, what that means specifically in a Fabric Copilot. But you see, one of the things that Satya had tasked all of the development teams with doing is making sure that we had a Copilot or AI exposed for every aspect of our business at Microsoft. So you see there's GitHub Copilots that allow you to do a lot of work with VS Code and development of code. You can see the Power Platform aspects and looking at how we can go ahead and use these experiences and bring AI into our workflows. Dynamics and CRM, we've provided that capability. Modern Workplace, and this is one I particularly like because it allows me to triage my inbox. So I can look at all the prioritization in my inbox and all the pieces that I want to go ahead and look at and focus on today. And it provides me with this assistant in providing that capability. In Copilot for PC with operating systems, we have that capability of looking at, I want to change, for accessibility reasons, the entire desktop. So it'll change the contrast, it'll change everything for that overall experience for me. And I don't have to do what I've done in the past, which is go through all the setup criteria to go ahead and change my desktop to make it an experience that's good for me. Browser and search, giving you the ability to browse very quickly, find content, utilize Bing. And I utilize Bing from a custom Copilot or from a development perspective of augmenting my searches. So my searches could be internal to my company using a pattern called relative augmented generative, which is bring your own data. And then I could use Bing to go ahead and supplement those particular pieces. And the last one moving on is going to be data and AI. And specifically today, we're talking about Fabric. So if you can move to the next screen. These are the copilots that we have today within a Fabric. So Microsoft Fabric as a data platform, we've consolidated all of our work, and you can see based on personas, a number of different pieces that we have available with Copilot. And we've already talked about utilizing Power BI to automatically generate reports, to look at summarization or executive summaries and doing those types of activities. Last week, we did a data factory session. In that data factory, we looked at data pipelines and data flow, Gen 2, to look at the opportunities to go ahead and transform the data very quickly. Today, we're going to be focused on the Jupyter notebooks and what that experience looks like, and looking at data engineering from data wrangling and data cleansing activities, all the way through to looking at experimentation and how you can use that with things like ML Flow to provide you with a very rich experience for healthcare. So with that, I will go ahead and turn it over to Arun, who will go into those particulars and talk about our partnership with iLink.
Hey, thank you, Greg. So let me just take you briefly through who we are. iLink was founded in 2002. It's headquartered out of Seattle. And we are a digital transformation solutions company, which means we, span the gamut of industries and of technology. We are very innovation focused. We are a very highly recognized Microsoft partner, recognized not just by the organization, but also, more importantly, the field teams. We have won 9 Microsoft Partner of the Year awards, and I think Microsoft will tell you that those aren't easy to come by. We have over 3,000 plus consultants globally, and most all of them, I think, working with customers who are exceptionally satisfied with us. We are spread across 25 global locations. Most, I would say, would be in the US and in India, where we, surprise, surprise, we have a lot of our delivery team sitting out of. But we do also have presence, for example, in Mexico, in Portugal, in Dubai, Kuala Lumpur, Singapore, in Toronto, etc. So we are fairly well spread out. From an offerings perspective, as I said, we span the gamut from digital strategy to data and AI, Salesforce, Internet of Things, robotic process automation, and so on. And we work across, multiple industries. If you look at the iLink Data and AI business unit, of which Munna and I are a part, we have over 850 plus data analysts, scientists, and engineers, more than 500 plus certified consultants, 30 plus, Fortune 500 customers, more than 300 plus Microsoft Fabric consultants. And given that Fabric is fairly new, I think, it tells you how quickly we've gotten on board, and obviously the fact that we are close partners with Microsoft helps in that. And we have, and you're very proud of this 20 plus years of Microsoft partnership. We are one of the very few who've also got advanced specializations in analytics and AI, machine learning, data warehouse migration, etc. So, I won't bore you anymore with this, but suffice to say that we've been around for a while and we've worked with Microsoft for a long time. So how have we invested in Gen AI? Like I said, we have the advanced specialization in ML and AI. We have over 35 plus data science and AI consultants. This is slightly dated. I think we have about 35 or so Gen AI specialists. We've done multiple Azure OpenAI roadshows in the US and Mexico. I personally have done about 9 in the US. We have a catalog of more than 35 odd Gen AI demos, accelerators, and frameworks. We are one of the very few vendors who are part of the Azure AI Partner Council. And we have also done successful Gen AI deployments for large companies. Okay. And I promise that's it. So let's get started, right? So as Greg said, copilots are everywhere. Now, how do you make sense of it? So this is a very simplified diagram of what Copilot or what the Microsoft Azure Copilots are. So if you go from the top to the bottom, you increase the complexity and you also increase the capabilities. You're essentially going from, out of the box Copilots, low code or no code pretty much. And as you go through, step through to Copilot Studio, where you can build custom Copilot apps using some code if you require, to building custom AI applications and managing the entire development lifecycle using Azure AI Studio, which again consists of prompt flow, AI search, or Azure ML Studio, where you can build your custom models, can do your ML ops, and along with Azure Vision Studio, where you can build your own computer vision models, right? So you have a host of solutions, a suite of solutions, depending on your requirement and use case, from low code all the way to the most complicated stuff that you could think of. Now, as I mentioned, this is a slightly more deeper model of the previous slide. And so if you're looking for out-of-the-box copilots, you obviously can go to Microsoft 365 Copilot or Dynamics 365 or GitHub and so on, where these are just embedded within these applications, and you don't really need to do much except click on the Copilot button and start asking questions and getting responses. Now, if you want to build your own Copilot, like the retrieval augmented generation models, RAG models as they are known as, very simply, you can just look at Copilot Studio to bake them, and they have a lot of integrations with, any number of different technologies and platforms available. You can deploy these in days. They're very low code and essentially help to democratize innovation. And then there are those who would have different use cases which are much more complex. And for those, you then can use Azure AI Studio and ML Studio. You can get your hands dirty. You can actually look into code. You can fine tune parameters and all of that nice stuff that I love. And so the point here is the time to value obviously is longer as you go from the left to the right, but the differentiation, going from just Azure AI infrastructure to best-in-class foundation models and up through this increases as you go from the bottom to the top. Okay. Now, when you think about an Azure AI application anatomy, at the foundational level, you have Microsoft Fabric, right? Now, obviously, one lake sits underneath that, but you have Fabric on top of it. And as Greg explained, Fabric just brought everything together in one platform, right? Now, interestingly, above that are the AI app layers, and they consist of 3 different platform layers. You have the data platform, where you could have your Azure SQL database or Cosmos DB or any other open source database that can plug in very easily. You can then have your app platform where it could be the Kubernetes service or container apps, app service, API management as your functions. And on top of that, you could then have your AI platform, which obviously you'd have your as your open AI. You would have model as a service. You'd have your machine learning, AI services, AI Studio, and so on. And connected to these AI app layers are your developer productivity suites. So Visual Studio, GitHub Copilot, et cetera, et cetera. So all of this obviously is underpinned by the AI safety and security aspect of it. And I know Microsoft pays a lot of attention to that, to responsible AI. So if you want to think about developing applications in Azure, AI applications in Azure, this is how you should visualize it and think about it. Okay. Right. Now, if you want to use Fabric, there are a couple of conditions. One, you need to have an F64 P1 paid SKU or above, and it's not available in a trial capacity. Two, the tenant admin must enable Copilot for you. So you need to talk to your tenant admin and cajole him to, enabling it for you. And it's not available in all regions. There are some caveats, but we can come to that later. But for the most part, I think in the US, it's available in a lot of different regions. So it should be very easy to get started with this. Right. So now that we've got all those initial pieces out of the way, let's get started with the demo. Okay. Now, look at that tagline, right? Anyone can be a data scientist. And I mean it. Okay. I've been doing data science for a long time. And I can tell you, I've never found it as easy to do data science as when I used Copilot within Fabric. It's just incredible. And I'm going to take you through that journey. So what are you going to see? What you see here is a typical data science workflow, right? For all your data scientists out there, you know that when you first get your data, they say that data scientist spends 80% of his time wrangling with data and 20% of his time actually working on models, which is true. But so you start off with data ingestion, and then you do your EDA or exploratory data analysis. You then, along with it, you do your data cleansing. You would probably do your data visualization, look at the data, see how it looks, how the distribution of data is. And once you do all that, that's when you start building your classification or your regression model. Okay. So I'm going to take you through this entire journey of what a typical data scientist would do. And I'm going to do it by letting Copilot do all the work for me. Okay. So let me share, let me pull the other screen here. And let me see. Yeah. Okay. So before I do that, I just need to show you what the data is that I'm going to be using. Excuse me. So it's a healthcare data set. It contains 55,000 rows of data and includes patient demographics, medical conditions, admission details, insurance, billing, and test results, right? So for example, in terms of patient details, it has a name, age, gender, blood type. It has your admission info in the form of medical conditions, the date of admission, hospital, doctor, insurance provider, and healthcare services, right? The billing amount, the room number, the admission type, the discharge date, the medication, the test results. So let's get started with it, and I will see what we can do. So just give me 1 second as I pull my, okay, all right. So the first thing I can do is, and I've done this little bit of, I've gone through this because it takes a bit of time to install, do the initial setup. When I say a bit of time, it takes maybe about 45 seconds. And I didn't want to waste that here. But what I'm going to do is I've opened Copilot. So you can go to the 3 dots here. There's a Copilot button. I've opened it up. And now I can say, hey, list files in the lakehouse. Now I have files in the lakehouse. Okay. So it timed out. So you're going to see, you have to sit through the 45 seconds or whatever it takes for it to run it again, because it disconnected since I wasn't there for about, I guess, 20 minutes. So just hold on a second. Hold on a few seconds and it'll do this. So again, you don't have to do anything. It does it all for you, downloads all the necessary packages, installs it. Earlier days, and I'm talking early 2000s, on a Linux machine, we'd have to go do all the hard work of downloading these packages, and making sure the version numbers matched. Otherwise, you would have to go down the rabbit hole of trying to match these version numbers. Thankfully, all that is a thing of the past. And I, for one, am very, very glad I don't have to do all that. Although on a rainy day, I might miss the challenge of having to do that. All right, there we go. So now I'm going to say list all my files in the lakehouse. Right? It's already doing. Okay. So what it has done is it has generated code for me. Okay. So I'm going to now, all I have to do is, you see this? It says insert code. So I'm just going to click on that and it's going to insert the code here. So there you have it. And I'm going to run this code. Okay. And it tells me that there's one data set called the healthcare data set. Okay. No big deal. So now I'm going to say, load this file into a data frame. A data frame is a Python data structure. So I'm just telling it, load this. I want this loaded into a data frame in the notebook so that I can work with it. Again, I insert the code. And you can see that it says, okay, insert it. I'm going to run it. Now, it's given me an error, okay? I know what the error is, but let's see if Copilot tells me what the error is. So I don't say anything. I just copy and paste the error and I click enter. And let's just hold on a second. And it says, okay, so it's telling me, it says, you need to import the pandas library before using it in your code, because the PD that you see here is actually, it refers to a library that's imported and named PD. So we didn't have that. So now it's given me this statement which says import pandas as PD. So I'm just going to copy and paste it over here and I'm going to run it again. Okay. And it's done. So now I've got the file loaded into a data frame. And now I can tell it, just show me the number of rows in data and also the top 5 rows. All right. So let's see what it gives us. So I just want to see how many, I don't know. I mean, yeah, I know, but let's see what it says. So I'm going to insert that code. Yes. I'm just going to change this to print top 5 rows. And now I run it. Okay. So it's given me the number of rows. It's 55,500. And it's given me the top 5 rows and every single column in those for those 5 rows, right? So as you can see, the gender, age, blood type, medical condition, date, etc., etc., etc. So it's given me all of that. Good. So now let's start doing some analysis on this. So if I say, let's perform, you remember what was the next step in that journey? So let's go back here and I'm going to go up. So the next step in the journey is the EDA, or exploratory data analysis. So I'm going to do that. And I say analyze DF data frame or data frame DF, however you want it. Import necessary libraries. So I don't want the errors again. And perform EDA on the data and give the code snippet. Okay. So let's see what it does. Now see how easy it is. I'm not writing any code. All I'm doing at most is maybe changing a line here or there. But for the most part, I just tell my lovely little assistant here, Copilot, what I want, and it does what it's supposed to do. Okay. So now, all right, I'm going to do a little bit. Okay, I'm just going to add a bit of code here because it's the same, but I've just added code for showing the histogram and the billing plot. And I'm just going to hit enter. All right. So it's still running, as you can see. Okay, so I asked it to provide me the histogram of age. Okay, and it's given me the billing box plot. Okay, so if that's the histogram for age, and if I go down, it gives me the box plot. What's the median amount? What's the third quartile? What's the max and what's the min? All right. So it's done some initial exploratory analysis. Now, I'm going to do some data processing. Okay. There might be some missing values. So I'm going to say analyze the data frame, perform data processing, remove missing values, also carry out outlier detection. Okay, outliers are there in every data set. So carry out outlier detection, make the necessary transformations for categorical variables. So when you have categorical variables like say male, female, when you're doing a machine learning, when you're using a machine learning model, you can't use male or female, right? So you have to transform that in a way where it will split that one column of males and females into two columns. It's called one hot encoding, where one column will say true or false or one or zero for male. The next column would say one or zero for female. And you've got to do this for every categorical variable. And so I'm saying, telling it explicitly, there are multiple ways of doing it. I'm saying use one hot encoding, import the necessary libraries, and give the code snippet. So let's see what it does. Okay, so it's given me code again, and excuse me, I'm going to run this. No, not this. That's the old one. Okay. So if you can see, what it does first is it's removing the NAs. Drop NA is a function that removes NAs, which are null values. It uses an algorithm called isolation forest, a model, to detect the outliers. Okay. And it's encoding all the categorical variables which are there, which are gender, blood type, medical condition, admission type, and it's using one hot encoding to do that. So let's see what it gives us. Okay. Okay, so as you can see, it's given, it's got all the gender, female, etc. But it also, let's see where it's doing the one hot. Yeah, there you go. So blood type, O negative, false, 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 or true. Medical condition, it split them up. Arthritis has its own column, asthma has its own, and so on, right? So this is the one hot encoding that it's been doing. Okay, all right, great. So it's done that. It's moved, it's cleaned up the data for me a little bit. Now let's do some visualization. Okay, so I'm going to say, I want a heat map. I visualize test results and the medical conditions. Okay, so I say, all right, give me a heat map of this. I'm sorry, but I can't assist you. That's okay. You shouldn't get discouraged. Just use try again. and try again. So I often say that the general LLMs are like recalcitrant 5-year-old kids. You have to be very patient, very nice with them. They don't often listen to you. They can be moody, but you've got to gently guide them. Okay, so here it is. You have, I'm going to run this, and voila, you have a heat map of the relationship between the test results, normal, abnormal, and inconclusive, versus all the other different medical conditions. This is an interactive heat map. So you could actually, if you, let me see if I can zoom in. So if I did this, let's say I did this, it would zoom in to just those conditions, right? And then I could always zoom out if I wanted to. Okay. All right. So I've done, let's do something again. All right, we can try and visualize the medical distribution by medical condition in an interactive bar chart with colored bars for each medication type. So let's see what it gives us. Okay, once again, it's given us the code. I get the code, grab the code from there, and here's the code. So run it, and there you go. That's your distribution of medication by medical condition. Okay, pretty cool, isn't it? You don't have to do anything, just ask and you shall receive. Okay, let's try something else. Colored bars. Okay. I'm going to ask it some simple questions now. Okay. Analyze the data frame and give the medication which gave the most abnormal and inconclusive results. Okay. I just want to know which medication had the most abnormal results or inconclusive results. So we can ask that. Grab the code as usual, and let's see what it does. So it says ibuprofen and Lipitor. Okay, now I want to ask which doctor produced the most normal results? Okay, so who's the best doctor of the lot? Mirror, mirror on the wall, or Copilot, Copilot on my desktop. You have to pardon the bad jokes, by the way. It's an occupational hazard for a data scientist. Okay. All right, let's grab this. And let's find out who the most normal doctor is. It's Michael Johnson. Wonderful. Not the track and field 400-meter great. Not him, somebody else. We can also ask for who was, which doctor has treated the highest number of patients, okay? And by the way, this is typically how it would go. I mean, data scientists would look at this, all of these things before even getting into the model building piece of it, okay? So again, I'm going to grab this code, get it into my notebook, and I'm going to run this. That's Michael Smith now. Okay, so we'll do one last before we head into predictions, okay? Why don't we look at the distribution of blood groups for the abnormal test results? Is there, do the blood groups matter when you're looking at abnormality in the test results? Which is a reasonable question to ask before you start working on a model, because you kind of want to understand what the data is and what kind of hidden patterns are available there. So let's see. And in this particular case, there really is not much of a difference. If you were expecting to say, oh, A positive or B positive has the most abnormal results, well, tough luck, because that's not what you're getting here. So That means that there are no easy answers. You can't really build a simple model to predict abnormality. So what we're going to do is we are going to now ask the Copilot to build us a machine learning model. Okay, so let's, and I've left this, there's a typo here. I'm not bothered. LLMs are smart enough to figure those out. So let's build a model to predict the success or failure of treatments using the following features. Age, medical condition, again, a typo here. Medication, gender, blood type as predictors. And the target variable would be the test results, right? So whether it's abnormal, normal, or inconclusive. And I'm going to say, all right. And remember, I'm also asking it to give me the accuracy at the end of it in the code. So it's going to give me the entire code for, if you've never built a machine learning model before, and your friendly neighborhood data scientist in your organization has dazzled you with a lot of buzzwords, you can now go and tell him, hey, I don't need you, okay? Because you can come to code, and it even tells you, right? It tells you what it's doing. It's selecting features in the target variable. It's encoding the categorical variables. It's then splitting the data into training and test sets, training a logistic regression model, okay? And then it's making predictions, right? So let's run this. And at the end of it, it's calculating an accuracy score of your predictions versus the actuals. So let's see what it gives us. So it's given an accuracy, this is 33.7%, which is worse than a coin toss. So it's not a great model. Now I can come in here and say, okay, can you give me code to build a random forest classifier? Okay, a random forest is just another type of classifier. So it's going to give me that code, hopefully. All right. So here you go. Grab that. And now you can see here. Okay. It hasn't. So it's already got all the train. So it's not giving me everything. It just is creating the random forest classifier, and then it'll predict the accuracy. So let's just run this. And it's given me 33%, which is okay. Which means I need to do a lot more analysis of the different, I need to check for collinearity. I might have to do other kinds of things, but we don't have the time for that. But you see how easy it is to build a machine learning classification model. Okay. Now, if I were to build a regression model, now a regression model is going to give me values for something. And in this particular case, what I'm trying to predict using a regression model is the billing amount. Given the age, the medical condition, the gender, the blood type, medication, the admission type, what should be the billing amount? If I want to build a regression model for that. So I ask Copilot to do it for me and give it a few seconds for it to work its magic. See, there you go. It's given me the code. So I just grab that. It does some very similar things. It's got the features, the target, etc. And then I run it. And there's an error. So the error, again, it will tell me, it said it could not convert the string to float. Now we can ask again why that is so. Okay, so let's ask. Okay, so it's telling me that the error indicates the admission type column contains string values that cannot be directly used in a regression model. and it's telling me how to do that. So I'm just going to, so I'm going to ask it, give me code to encode admission type. Okay. I don't even want to use my brain for this. I could do it, but I have a trusty assistant that I can use. So there you go. So it's now giving me, you know, it's giving me a way to do it. I'm going to do it my own way though. So I'm just going to say, hey, listen, this is how I would do it. Okay, I'm going to just say, do this, and then I'm going to change this to encoded. And now hopefully it will work. Okay, and it's given me a mean squared error of this. I can ask it to give me a root mean squared error or other types of accuracy. But the idea here is that it's now built a regression model. So if I need to, I can give it all of these features, the age, the medical condition, gender, blood type, etc. And I can then predict using this model. Okay. I have come to the end of the demo portion of it. I hope this at least kind of gave you a sense for how you can use Copilot to pretty much, for anybody to now do exactly what a data scientist does, which is go through this entire cycle, ingest data, do exploratory data analysis, do data cleansing, do some data visualization and data exploring, build ML classification models, build regression models if you want. The entire shebang is now, just a few clicks away for you and a few prompts or queries away. Okay. All right. So, Greg, do you want to take this or for Copilot Studio, or do you want me to go through it?
You're on a roll right now, so go for it.
Okay, so pretty soon what we will be coming up, and I say we, Microsoft and us, will be another webinar, hopefully, in the near future, where we will work similarly through Copilot Studio, cloud-based. So Copilot Studio is a cloud-based development environment that allows developers to code and collaborate on projects. It's got a full-featured code editor. It supports multiple programming languages, and it really makes coding faster and more efficient. It's got a collaborative workspace so that multiple folks can work together. Developers can share code, files, projects, etc. And most importantly, it's got integration with Azure services. See what the Copilot that I just showed you did is it gives you code that you then import into Notebook and work. So there's still some element of, the fact that you need to know coding in there. But here you can, it runs a spectrum from no code to low code. So in a sense, because it has all these point and click integrations with other Azure services, include Azure DevOps, Azure functions, it makes it very easy for developers to build and deploy and manage their applications. Okay. This complicated looking diagram is the Copilot Studio architecture. So at one end of it, you have all the different channels and many more actually. And I'm sure you recognize a lot of these icons. You have the Azure Conversational Language Understanding CLU optional module here. You have a number of agents that are part of it, and you can customize each agent to a particular topic. And those agents then make use of Azure OpenAI and Azure AI Search to provide you the answers. You obviously have connectors, various types of connectors, and which can then use to build your application. So a Copilot Studio basically helps you build applications, and it's really very simple. I mean, I've built or my team has built applications in like half an hour, come up with something quick and dirty, which works beautifully. It might not look the prettiest because if you want, all kinds of fancy bells and whistles on it, it'll take a little more than half an hour, but you can do a lot with, you want to come up with a quick demo, you can do it very, very quickly in this. Okay. And you can also come up with a production level solution if you want to. Okay. All right. I think I need to hand it off now to Christina. You want to come in for the latest announcements?
Oh, actually, we're going to have Greg handle the announcements. We have just for
Okay.
Data Wrangler, and then I will continue from there.
Okay.
Oh, great. Oh, I've got a lot of background. Go ahead, Christina.
Okay, well, we'll keep it simple. So I know from previous webinars, we have talked about the different types of, roadmap release items that have come up in the recent time, especially with the launch of Fabric Copilot. There's been many. On the data science side, we just have one update that's coming through for, this is for Q1 for 2025. And this is actually something that's going out into public preview. So as you're probably familiar, public preview is something we're testing. It's out there live for you to try out, but we are also still working in development. But just to give you a little heads up on what this is this is an AI-powered operation. If anyone's familiar with Data Wrangler, it's we're using this to describe code transformations. Obviously, the focus is on natural language as Fabric Copilots. And this is corresponding to Python, and we're doing some translations with custom Python code and PySpark code and Synapse ML transformations. So, in the spirit of AI, text translations and sentiment analysis are a big part of this. So this is really what we're putting that big focus on for anyone that is familiar with that. And also, we just want to mention too that our Fabric conference that we had in Europe that had taken place back in September, we wanted to still reiterate some of the exciting features that had come out. So we do encourage you to check out the blog for Fabric, the Fabric Community Conference, and we will add that into the chat.
Okay, and just a few iLink digital resources. We have some case studies in the partner portal. We also do 2-day workshops, 5-week proof of concepts, 2-week hackathons as well. For Gen AI, we've got Fabric 4-week proof of concepts, Fabric Copilot, a 1-day workshop, Fabric data modernization, and Power BI migration accelerator. So these are just some of the ways that we can help you. And yeah, I think we can move on. Oh yeah, and there's a lot of other resources for getting started with Microsoft Fabric Copilot. So, you can go here, go to all these different links, and I think you will have more than enough information to get started, at least. Okay, we're now at Q&A.
Also, I want to bring one other item up just to be aware. Keep in mind that we are going to have recordings that are going to be posted to the webinar blogs that we have. I sent those out in the very beginning. And then also, we are looking to extend our Fabric webinar copilots and actually more into Fabric itself as well. So please stay tuned. We'll be sending out some information in our blogs about that as well. So definitely follow our posts and videos to get more information as we go on. So just want to leave that open, and our Q&A is here. So we definitely ask questions in the chat, and then we'll be able to wrap up. I did see one in the chat. I think Luna had already responded to.
Okay. Don't be shy, folks. Put your hands
There's
up.
a question
Do
from
ask questions.
Swati, Arun.
On chat?
Yeah.
How come I don't see it?
In
Can
the
you just...
Q&A, in the Q&A.
Oh, in the Q&A. Okay. Let me...
Yeah, there was one question on helping track a patient longitudinally.
Can you... Yeah, go ahead.
Manu answered, but didn't know if you wanted to expand any more on that one.
First of all, what do you mean help track a patient longitudinally?
It must have been based on the demo, but if whoever asked that question is still available, if you can,
if you can
come
just...
off mute, we can get into more detail.
Yeah, this is Swati. What I'm looking for is when we look at their history, there might be additional other conditions. So if you, for example, if someone gets hospitalized multiple times, so the chances of rehospitalization is an important metric for us to track. So each case, from what I saw in the database, is one hospitalization, but same patient may be hospitalized twice, thrice in the last whatever period you define for analysis.
Yeah, so I think that's a great point. And as you noticed, the accuracy figures weren't that great, right, for the predictive model. And that also meant that there's probably some missing information in there. And perhaps one of that is, the number of hospitalizations. So I would actually use that. So the way, a data scientist should typically work is with the subject matter experts. And somebody like you who comes and says, hey, you know what? This data set doesn't have hospitalizations. That would be an important clue for us to say, we need that data before we go ahead and build a model. Does that answer your question?
Yes, no.
Okay, let's hear the no. We have some time. That's okay.
It's just that what I'm trying to, so let's say if we have a data set, an EMR data set, for example, for a large hospital, and we want to see what's happening, right? Because a lot of times, and now even more so, Medicare is not about, it's value-based care, right? So based on the output or outcome of the patient. So that is where, if that's the data set we're working with, I'm just trying to think about, can my machine learning model help me identify and see how the patient with X condition, how many times have they been hospitalized post a particular procedure, for example?
Oh, okay. I get it. So you are there are ways to do it. There's something called survival analysis, which is often used with healthcare data, like for example, with cancer patients, right? You could turn that around to predict the number of hospitalizations as well, because there are ways to do it. That's what I'm trying to say. There are models that, but again, the one thing you need to remember with any and all machine learning approaches is that it depends a lot on the data. So if you don't have the right set of data, once you have the data, like I said, 80% of your problems solved. Then you need to figure out what model to use, what kind of model based on the kind of data you have, should you be using. And that's why perhaps data scientists will still have a role to play, because Copilot can't really do it at this point in time, which isn't to mean that Microsoft might come by in one year's time with a healthcare Copilot which can do it. And then I will have to rethink that point.
Thank you.
Thank you. Dhanushika, I see has a raised hand.
Yes, Arun, how are you? Hope you're doing good.
Yes, I am. Thank you.
Yeah. My question is not about the healthcare domain, but my question is like, will we able to use Copilot for fine tuning our LLM model in the near future?
Using Copilot to fine tune an LLM model, they kind of Copilot is an outcome.
Because we have seen like there was the accuracy of certain models were like quite low. We can fine tune it to from 33. We can fine tune it to 67 like that.
Oh, you
That's
mean
what
the
I'm trying to
ML
ask.
models? Yeah,
Yes.
you can actually ask Copilot to give you code for hyperparameter tuning, and then you can use that to run. But the only reason I didn't do that is because hyperparameter tuning can take minutes to hours to get done. So I didn't want to do it right here.
Like, why can't we write a fine-tuned query code with
Sorry?
of around seconds? Like, sorry, like, am I audible now?
Yes.
Like, why can't we write the code which we can be tuned within seconds rather than going for minutes?
No, hyperparameter tuning is think about it as a grid search, right? Let's say you have 10 parameters. Each parameter, let's assume it goes from 0 to 1. Okay, that's a vast space. And in order to search that, you'll have to try pretty much. There are different ways to do it. There's gradient search and all. But if you did exhaustive search, it would take you days to do it because the parameter space is so vast. So there are optimization techniques that you can use to do it, but it still requires time for it to run through each of these, because what it will do is for each combination of parameters, it's going to run your machine learning model again. It's going to build the model to predict it, get the accuracy, and then see if the accuracy is better than the previous best that it has. If not, then it's going to run the other one, next one again. So it takes time to do all that for the repeated runs.
So Arunji,
Okay.
on the top of that, I would like to add. Dhanushika, there are the two things. See, as Arunji has said that the sample space exploration, right? That's wide, that's huge. Second thing, hyperparameter tuning it's a compute intensive task, right? So if you have more power CPU, then it can be handled very well. At the same time, there are some techniques like Bayesian optimization technique, which will help you to expedite it. I hope that's answer your question.
Yes, like I have to learn some more on machine learning, I guess.
Keep learning.
Yeah.
We have a
other
couple more
questions?
minutes until we're closing out. We have about 2 minutes left. You want to get some last minute questions?
So you can unmute and ask your questions.
Yeah, but I have a question.
Maybe a fundamental. Yeah, please go ahead, Vishal.
I want to know if you had mentioned a Copilot PBI feature. I want to know if that was already launched inside Avid, or is that planned to be launched? And if it's planned to be launched, when can we expect to start taking advantage of that?
I actually responded to that question because I know I've been working with Abbott.
Okay.
That is something that does require you to have your Fabric admin be able to enable it either for your entire organization or enable it for specific user groups, security groups, or individual. Yes.
Okay, so if I work in a subdivision and let's pretend bigger divisions have enabled this for their division, it is possible that my subdivision will just say, well, we don't want this feature, but the other divisions can use it. That is another reality where we have, like, I guess it's determined to whoever the division leaders are, whether this is going to be coming down or not. Is that correct way to assume that?
Yeah, and I feel like in this situation, if you'd like, I can take this as a call with you and any others that have that concern. We can actually help you and walk through the Fabric admin portal with you on those changes, like so we can get better address it.
Well, my concern is not on the development side. I actually have a designation in BI and business intelligence. And my concern was currently in the subdivision I work in, we kind of just use Excel, right? We haven't really went up from that. So when I saw the presentation, how you guys use Power BI, which is something that I specialize in, I saw the copiloting feature where you can create dashboards through prompt engineering. And I saw it as an opportunity because right now we don't create them as fast enough. But I feel like with Copilot, we can create maybe like 6 or 7 a day, right, with the data we already have. But right now we're just not getting that time frame out of it. So that was my concern, is productivity and efficiency, and also reduction of manual labor with the implementation of this. So that was the why behind my question. But I appreciate you answering.
Oh, yes, of course. And we can definitely, if you'd like to take this offline with myself and others here, we definitely can give you some more information on what's coming up with pilots. Okay, thank you.
Thank you.
And we are at time. So I just want to give a big thank you to iLink. Thank you to the Microsoft folks that are also included in this, everyone that's attended. We will definitely be in touch when it comes to any new webinars that we are now planning. So again, thank you, everybody, and hope to see you at the next one.
Thanks, everyone. Bye-bye.
Thank you.
Thank you.
Thanks,
Thank you, everyone.
thanks, Tarun.
Thank you,
Thanks,
everyone.
Greg.
Thank you.
Thanks, Christina. Thanks for the session. It was really insightful.
Thank you.